Okay, so I've hand augered a borehole here using this Dutch or Ewan type auger. Kind of a silty clay with a little bit of sand here. Could be CH, probably CL. After that, I'm going to use the trimming shield here. So this was actually designed to go around the shear head, and as you lower it in the sand, you would carefully route your wiring and everything, but have this around the shear head and have the shear head kind of pulled up, retracted in here. You would have your, I'm not sure how Dr. Handy did it, but you had your cables going up like this, and the idea is you would get to depth, lower this down, do your test, and then pull it back up. So it protects the shear head in the sands. What we use it for mainly is like a nice Shelby tube to trim the borehole for a hand augered borehole in cases where you don't have a drill rig and you can't get a Shelby tube pushed. So I've augered that borehole here. This is down to I think a 3-inch diameter auger here. Most hand augers you get tend to be like 3 1/4 inches, and in that case you want to grind off the ears so that it's not oversized. So the best thing to have here is a 3-inch borehole. So this will give us a nice smooth surface of the borehole. Not quite as good as the Shelby tube, but by pushing and turning, we'll prepare a decent surface to test here. So these are just lengths of pipe you get at any home improvement store, and you can add sections on, make it as long as you like. I can hear there's some rocks down there, some gravel pieces going by. But I just take this to the depth I want to test. Kind of use this to ream and trim the borehole. And be kind of shallow here. Really probably just the depth of this trimming shield itself. So I've got some material there that's kind of cored out a little bit, and that should leave a good quality borehole to test. So I'll get a screwdriver, clean this material out, or just get with my finger here. Another thing you can do is if you have like a 2-inch drive sampler, a hand auger with a drive sampler set, you can do a drive sample with a split spoon, get your sample, and then use this to core out a donut to ream the hole bigger. That works pretty well too. And there's a nice piece of aggregate or bone. I think this house used to be a pig farm. Okay, so I've augered down about 15 inches here, and what I like to do is, in a hand augered borehole, I like to put the shear head all the way down to the bottom of the borehole, and then not really run it with it resting on the bottom, maybe pull it up an inch or so that it's not resting on the bottom. We will be pulling up, but we'll also be unloading between stages. So at the end, you're down at the bottom and I pull it up, say, an inch. Basically the center of the shear head will be 2 inches above the bottom of the hole, roughly. So for a 15-inch borehole, if I do that by pulling it up an inch, I'll call that depth 13 inches for the test step. Another thing we like to do is orient the shear plates, maybe north-south, and then do a test, and then clean them off, put it back in the borehole, rotate it 90 degrees, east-west orientation, test at the same depth. So you're getting the same depth in the borehole, just 2 different orientations, 90 degrees from each other, and see how consistent that is. So we'll go ahead and do that in this test here. So I'll get a rod. And 1 pull rod should be enough here. Thread it on. You may want to get some vice grips. As these get dirty, they get a little hard to screw and unscrew from each other. Wire brush can help you keep the threads clean as well. But I would put that in. You may have to go apply a little bit of pressure and retract the shear head. So let's see. You can see this. Yeah. So I'm going to go ahead, slowly screw in this cap on the pressure bottle, stand out of the way. Ideally, hold on to this in case it blows off. It's not going to come and hit you. Safety glasses might be nice here. But then you feel the pressure, stiffen the hose here, and now I have CO2 supply to my regulator here. So I can attach this, which we previously did, through the black and white pressure hoses. Put this in manual mode, increase the pressure 10, 20, maybe 30 kPa. It's only about 5 psi. And we see the expand, retract operation. And I want to put it down the borehole in this retracted position. I don't have the pressure control electronic cable in there, so it's not going to be bleeding off that pressure yet. And also the power, I don't have the power on here anyways. But this shear head, good condition, stays in the closed position here. So you can put it down the hole. Sometimes you may want to have it in retract when it's far down the hole, you don't know what's going on. Have some retract pressure as you're pulling this up out of the ground. So I'm going to orient these shear plates north-south, this first test, all the way down to the bottom. And the hanger here is just below ground level. I'm going to pick this plate up, not by the cross plate here. Place it down over the top, and just route this cable out of the way. Pull off the hand crank, because we're not going to do a manual test. Put that away, and hopefully you never need to use that. But just above that, in the case, there's some other goodies. You need to have this rod clamp. There's a screwdriver in there for you. There's a nice T-handle Allen wrench to tighten this rod clamp. This rod clamp goes down the rods. Make sure to have the side with the recess, the plus-shaped recess, down so that it can actually lock on. And we've got a few other things in here. So I'll take out this planetary gear, horizontal planetary gear. Goes this way down. Goes into the thrust bearing. Direction I like to have the thrust bearing is, the outer case down, inner case up. But I suppose it might not make too much of a difference, but I think this is a little better. And then there's an Acme threaded rod here that goes through, and you want the Acme threaded rod with these machined pluses coming up out of the hole. So screw that in, and actually, to give ourselves the most amount of distance to test, we want to start with this just protruding a little bit from the planetary gear. Then this will rest on the thrust bearing, that rests on the cross plate, and then by locking this onto the rod, then as we turn the hand crank, it'll turn this planetary gear. There's a worm gear on the hand crank, or the motor turns it actually. Turns this planetary gear, which if this is now locked in to this recess here in the bottom, it'll stop that from turning. So as this is rotated, there you go. It's easier when it's assembled on the rod. Our rod clamp will rise and pull the rods out of the ground, giving us our shear stress. So important thing, this plus goes in this recess. Also, when you get it on the ground, you may start a test and it looks like nothing's happening. That could be because these are not locked in, and this Acme threaded rod is just rotating underneath the rod clamp here. So rod clamp, direction-wise, I like to put the Allen screw on the opposite side, away from where the box is, and then this U-shape here locks in between those pillars, which just provide a reaction to stop this from turning. So I'll assemble that. So the thrust bearing, Acme threaded rod, planetary gear. Okay, it fits in, it locks in, meshes with this worm gear here that's turned by the motor. Rod clamp with the pluses on the bottom. Allen screw out. And as these things get worn, they can get a little bigger. I like to take some vice grips and help squeeze this closed as I'm tightening it to give some extra closure force as I tighten it, and then take the vice grips off during the test. So this is a brand new one, so it should be fine. And depending on how clean or dirty your rods are, this may be easier or harder to get down there. So loosen this up. A little bit of lubrication might help there. So this is down, but I'm going to now turn this Acme threaded rod until it locks in. Okay, now I feel it's engaged, the rod clamp, and we're good to go. Just need to lock this in. so that it clamps on the rods. So you want to get this pretty snug, as tight as you can. And if for some reason you suspect this is slipping on your rods, maybe they're getting old or they're kind of oily, I would just take some tape, any kind of tape, you know, electrician's tape or just ordinary Scotch tape, put it on here and then see, you know, did it bunch up, did it pull up relative to the rod during the test. So lock this in, make sure my rod is locked in. And common mistake, I still had the borehole, or the shear head at the bottom of the borehole. So I said I want to raise that up about 1 inch, right? So now it's not resting on the bottom of the borehole. That's actually important because we want to measure the weight of the shear head and the rods. The more rods you add, the heavier this weight will be hanging. That reads as a shear stress on here that we have to subtract off. The program will do it automatically. If you're doing a manual test, you'd have to read right now, okay, about 1 or 2 kPa is the weight of the rods and shear head. We've only got one rod, so not too heavy. But that's not applied to the soil. Shear head is not expanded yet, so that's a tare value that we want to subtract from all of our readings to get the actual shear stress applied to the soil. Okay, so we got the shear head lifted up, got this locked in. Take my BNC cable, plug it in for the reading of this pressure here. The software will also take a reading of what this pressure is here and store it as the tare value and subtract that from everything while it's running. And last thing, connect our larger multi-conductor cable. Maybe keeping these gray ones, you know, separate from the black BNC cable that's got the lower voltage signal. Now, the base plate, if the ground is uneven, you can shim up, get this to rest on some boards. Usually take a shovel, level off a nice area so you get a nice firm platform. As we start shearing though, everything is going to kind of tighten up and squeeze together, and some of our displacement, or displacement of the rod relative to the cross plate, is just going to be from, you know, tightening everything up. So, very common mistake here. If this cable is not fully locked in, basically the stepper motor won't operate. And if we do some troubleshooting, it would say stepper motor has an open winding, an open coil. That's just because the wire is not going through and completing the circuit. So make sure this is locked in. I've actually got a little scratch on the top center of this, so when it's locked in, this should be the one that has a little light etching in the middle, should be straight up and down. Then you know it's fully plugged in. Okay. Just going to check that these are all good. And lastly, you want to check the orientation, kind of get things nice and vertical and aligned. You don't want your rod coming up at an angle. It is going to be applying downward pressure to this cross plate, which is going to be measured by the oil in these two cylinders, which are hydraulically attached, so they should share the load. But still, you want to have good alignment so you don't have some friction influencing your results.